Guys, hi, welcome back.
So in this video, we shall see the numericals related to the electric field intensity. So in the previous video, we have seen related to the Coulomb's law, right? So let us see the first question here. Here it says, calculate the magnitude of electric field, which can just balance a deuteron of mass 3.2 into 10 to the power minus 27 kg. So you have a deuteron and the mass of the deuteron is given to you. And you need to calculate the magnitude of the electric field, which can just balance the mass of the deuterium. Okay. So for this, firstly, what we will see is the formula for electric field. You know, electric field is force per unit test charge. So from here you can write force is electric field into with the charge. Clear? So this particular force is the electrostatic force, and we need to balance out this electrostatic force. Okay, so that the mass of deuterium will remain balanced. Okay, it will not move. So this electrostatic force will be balanced by the weight of the deuterium. Okay, so what we will write directly is the electrostatic force is equals to the weight, because the force which balances the electrostatic force will be the weight of deuterium. Okay, the weight of deuterium will balance the electrostatic force. We know the formula force is charge into with the electric field, right? F is equals to what? Q into with E, and here we are having mg. So from here you can write the value of electric field just by calculating, right? So E is equals to mg upon Q. So E is equals to m is the mass of deuterium, which is 3.2 into 10 to the power minus 27, and acceleration due to gravity G is 10, and charge of deuterium is plus 1. Okay, that is charge of electron 1.6 into 10 to the power minus 90. So when we do the calculation, 16 to the, and here you can write E is equals to 2 into this is 10 to the power minus 26 minus 27 plus 1, and here you will have what? Plus 19. So directly what you can write, E is equals to 2 into, from here when you will do the calculation part. Okay, this is 26 and this is 90. When you will subtract, you will get 10 to the power minus 7 Newton per coulomb. So this is the electric field which balances the mass of deuterium. Clear? Now let us see the next question. Question number 14. Here it is said 2-point charge of 2.0 into 10 to the power minus 7 coulomb and 1.0 into 10 to the power minus 7 coulomb are 0.01 meter apart in weight, and you need to calculate the electric field magnitude by either charge at the site of the order. So it's simple. You're having two charges, okay, Q1 and Q2, and the distance between them is 0.01 meter, okay, and it is in vacuum. Clear? So the value of the charge here is 2 into 10 to the power minus 7. This is 1 into 10 to the power minus 7. So E1 will be the electric field due to the charge Q1, and E2 is due to the charge Q2. We know the formula is what? K Q1 by R square. This is also what? K Q2 by R square, right? So it's very simple. You write E1, K is 9 into 10 to the power 9. And charge value Q1 is what? 2 into 10 to the power minus 7. And here what you are having? 0.01. Okay, that is 1 by 10. And one more 0, 100 whole square. Okay, so you can write E1 is equals to 9 to the 18, right? Here 10 to the power 9 minus 7, and this will become plus 4. Okay, this is what it is. So when you will do the calculation, you will get this is E1 is equals to 18 into 10 to the power 6. Further, you can write E1 is just when you treat the decimal 1 point, here it will be 1.8. This will become 10 to the power 7, right? This will become 10 to the power 7, because when you will divide here by 10, you will multiply also. Just 10 by 10 dividing. So 18 by 10 is 1.8. This is 10 to the power 6 and 10. Now we will calculate E2. So E2 is also same, 9 into 10 to the power 9. your value of charge is 1 into 10 to the power minus 7 divided by r square, that is 1 by 100 whole square. So here if we see the entire 10 to the power 6 will be seen. This will be just 9 into 10 to the power 6. This is Newton per coulomb. Okay, this is Newton per coulomb. This is your E2. This is also Newton per coulomb. So you were just asked to calculate the E1 and E2 value. Okay, that is the electric field due to either charges. Clear? Now let us see next question, question number 15. So here it is said an alpha particle is situated in an electric field of 1.5 into 10 to the power 5 Newton per coulomb. So this is the value of electric field in which a alpha particle is situated. So you will have to calculate the force exerted on it. So we know it's very easy to calculate the force using the electric field formula. E is equals to force upon the electric field. So force is what? Electric field into with the charge. So it's simple. F is equals to electric field is 1.5 into 10 to the power 5. And what we know, the alpha particle, it has charge how much? Twice of electron. That is 2 into 1.6 into 10 to the power minus 9. This is the charge of electron, right? So we can write from here, F is equals to 1.5 into 2. 15 to is 30 and point will come here. So it will be just 3. Okay, into here you're having 1.6 and this is 10 to the power minus 19 plus 5. So you will have here 10 to the power minus 40. Right? So 3 and 16. So this will give you 4.8. Okay, into 10 to the power minus 40 Newton. So this is the value of the force. I think this was a very simple question and very easy question. If you know the charge of alpha particle, the question will be very easy. So you need to remember the charge of alpha particle deuterium. Okay, now let us see the last question of this video. So here it is said 4 point charges minus 2q plus q minus q and plus 2q are placed at the corners of side 0.02 meter. Find the magnitude and direction of the electric field at the center of the square if q is equals to 0.02 microcoulomb. Here corners of side. Okay, this is corners of a square. This will be there. Okay. So question is simple. You're having 4 charges. Okay. These charges are placed at the 4 corners of the square. So this is a square. I'm just marking the 4 corners to be A, B, C, and D. So the first charge is plus 2q. I'm placing here. Minus 2q. I'm placing here. Again, I'm placing. You can do either way. You can just put minus 2q here and plus 2q here also. It will make no difference. And here you can write minus q. Here you can make plus q. It's completely your choice. Okay. Now you are asked to calculate the magnitude and direction of electric field at the center. So for this, you will draw the diagonals. Okay, this way, and this is your center O. So here, if you see, the sides are given. Okay, all the sides of the square are equal. So AB equals to BC equals to CD is equals to A. And it is your 0.02 meter, which you can write as 2 into 10 to the power minus 2 meter. Okay. And now you will calculate first the diagonal. Why? Because we know electric field formula is KQ upon R, right? And R is the distance of the source charge to the test charge. So here we are considering this point O where we will place the test charge. So we need to know the value of AO, right? And AO is what? Half of diagonal. And we know in case of a square, both the diagonals are equal and the diagonals bisect each other. So this AO, BO, OD, OC, which is the distance of all the 4 source charges from the point O where the test charge is. Okay, so we will calculate first the diagonal. We will consider one triangle, right angle triangle, and we'll calculate either of the diagonal. Okay, so first let's see in this case in triangle BCD and consider. I'm considering this triangle. This BC and D. Okay, this triangle, if I take the Pythagoras theorem, I can write BD square is equals to BC square plus CD square, right? So BD square is equals to, you see BC and CD, these are the sides of the square, which is 2 into 10 to the power minus 2 meter, which can be written as 2 centimeter, right? So we'll write here this is 2 square plus 2 square, that is 4 plus 4, 8. And we can write here BD is equals to 2 root 2 centimeter. Now what we will have, AO equals to this BO equals to OC equals to OD, that is half of the diagonal, that is half of PD, that is half of 2 root 2 centimeter. 2 and 2 gets cancelled, and you can write this to be 2 root 2 into 10 to the power minus 2 meter. Clear? Now we will see first the direction of the electric field, and then we can calculate the magnitude of electric field. So we know that the electric field is having the same direction as the force, right? So we know positive charges have what? Both the positive charges have repulsive force and opposite charges. Okay, one is positive and the other is negative, and they are having attractive force. So here you are having a negative charge, and we know the test charge placed at O is always positive. So your electric field EA is in the direction of A because the force is attractive. Similarly, this will be also EC will be also in this direction, but this is positive, this is positive. So EB will be in this direction, and similarly AD is in this direction. Now you have to see the magnitude of this and this charge. This charge is having greater magnitude. So obviously the electric field, final direction of electric field will be along EA, that is E1. And in case of B and D, the charge placed at B is 2Q, and here it is plus. So the final direction of electric field will be along EB, that is E2 charge. So here what you will see is this is your E1, okay? This is your E1, and this is your, just a second, sorry. This is your E2. This is your E1. So the net resultant will be in this direction. That is, this is the direction of the electric field at the center. So first of all, let us calculate the value of EA, EB, and EC, ED. Then we will go for E1 and E2. So if you see here, EA and EB, this will have the same value because they are having the same value of the charge also. So here it is, we know electric field is KQ upon R square. Okay, this is R square. So here, this will give you a square here. Okay, there is a square. So K is 9 into 10 to the power 9. The value of the charge is 2Q. Q is your 0.02 into 10 to the power minus 6, right? Divided by R square. So here R is root 2 into 10 to the power minus 2 whole square. So let us do the calculation. So 9 2s will give us 18, right? Here we will have 18 into 10 to the power 9 minus 6. From the denominator we will have 4, right? And in the denominator this side we will have 2, and this 0.02 can be written as what? 2 upon 100, right? This will be 2 upon 100. So this 2 and this 2 will get cancelled, and from here we will get 18 into, this is 9 minus 3 is what? 9 minus 3 will give you 7, right? So this, you see, this is 9 minus 6 is 3, 3 plus 4 is 7. So this is 7, and in the denominator again minus 2, so you can write 18 into 10 to the power 5 Newton. So this will be also 18 into 10 to the power 5 Newton. The same thing, and similarly if you see EC and ED, okay? So any one calculation you can do, same 9 into 10 to the power, 9 will be there, this is 0.02 into 10 to the power minus 6 will be there, divided by R square, which is your 2 into 10 to the power minus 4. So from here it will be same 9 into 2 upon 100. Okay, this is 10 to the power 3 and plus 4. So it will be directly what you will get here. This 2 is here. So 2 and 2 gets cancelled. 9 into 10 to the power 7 minus 2 is again 10 to the power 5 Newton. So this is the value for EC and EDS. So finally, when we will write E1, what we know in case of E1, we have seen that EA was greater, right? So it will be EA minus with what? The other one, EC. Okay, we were having this where the vertices were there. Okay, this is A, B, C, D. So this side we were having what? EA, and in the other side we were having EC. So it will be EC. And similarly for E2, what we will have? We will have EB minus with what? ED. So we know the values here. We were having EA to be 18 into 10 to the power 5, and this was 9 into 10 to the power 5. So I'm writing 10 to the power 5 I would say. And similarly, this was also same 18 minus 9 into 10 to the power 5. This is just putting the values, and you will get here this is 9 into 10 to the power 5. This is also 9 into 10 to the power 5. This is E1 and E2. Now you see your E1 was in this direction, E2 was in this direction. This was your net resultant. Okay. When you know the vectors, you can write the resultant is what? Root over E1 square plus E2 square plus 2 E1 E2 cos theta. This cos theta, this cos theta will have this theta as the angle between E1 and E2. If you see here, these are the bisectors of the diagonal, okay? And we know the diagonals of a square are bisected. That means this angle is what? 90 degree. So cos 90 is what? 0. So finally, you will write here your net resultant. Okay, resultant electric field is what? Root over E1 square plus E2 square. Now here if you see both the values are same. E1 is equals to E2. So you can write here E1 square plus E1 square. That is what? 2E1 square, which can be written as root 2 into with E1. That is root 2 into with 9 into 10 to the power 5, right? This is what you can write. And when you will calculate it further, okay, you can just put the value of root 2, and when you will do the calculation, you will get the answer to be 12.726 into 10 to the power 5. This is 10 to the power 5. This you can do it on your own. And if you see here, this line, it is parallel to what? This net resultant electric field, it is parallel to AB. So you can add here, this is parallel to A. So these questions were very easy. You just need to know the basic concepts and you are ready to complete all the questions. So that's all in this video. Thank you so much. Have a good day.